teacher Neth, and welcome back to our statistics and probability class. By now, you know already what a discrete random variable is. This time, basically, you will know about the listing of all the possible values of this discrete random variable. So let's start. A discrete probability distribution is a listing of all possible values of a discrete random variable along with their corresponding probabilities. It is also called as the probability mass function. And it can be represented in tabular, graphical, or formula form. There are two properties of a discrete probability distribution. These are, first, the probability of each value of a discrete random variable is between 0 and 1 inclusive. That is, p of x is greater than or equal to 0, but is less than or equal to 1. And second, the sum of all probabilities is 1. That is, summation of p of x is equal to 1. Let us have some examples.
Example 1. Determine whether the following distribution is a probability distribution or not. So this is the given table where the first row pertains to x, or the values of the discrete random variable. And their corresponding probabilities are in the second row, or p of x. We know that a probability distribution satisfies two conditions. The first is that each p of x value is between 0 and 1. And the second condition is that the sum of these p of x's must be equal to 1, exactly equal to 1. So for the first condition, we know that each of these, when you try to look at each p of x value, we can see that each is between 0 and 1. So for condition 1, check. And then for condition 2, the sum total of all p of x values must be equal to 1. If you get the total of these 5, you'll notice that it is equal. Their sum is equal to 1.05 and not equal to 1. Therefore, condition 2 is not met. So, it is not a probability distribution. Example 2. The spinner below is divided into 8 sections. Let x be the score where the arrow will stop, numbered as 1, 2, 3, and 4. Letter A. Find the probability that the arrow will stop at 1, 2, 3, and 4. B. Construct the discrete probability distribution of the random variable x. So this is the given spinner in example 2. We are asked to solve for the probability that the arrow will stop at 1. And then for the probability that the arrow will stop at 2, then that the arrow will stop at 3, and lastly, the probability that the arrow will stop at 4. So let us begin with p of 1. This means probability that the arrow will stop at 1. There are 8 sections in total, and there are 2 sections which are numbered 1. Therefore, there are 2 possibilities that the arrow will stop at 1. 2 over the total number of sections, which is 8. So, the probability is 2 over 8, or in lowest term, that is 1/4. Again, that is the probability that the arrow will stop at 1. The total number of 1, sections which are numbered 1, over the total number of sections, all sections. So, 2 over 8, or 1/4. For p of 2, or probability that the arrow will stop at 2, since there is only one section which is numbered 2, then that probability is 1 over, again, the total number of sections, 8. So 1/8. For p of 3, or probability that the arrow will stop at 3, how many sections are numbered 3? There are 2. Therefore, the probability is 2 over total number 8. 2 over 8, or 1/4. And lastly, for the probability that the arrow will stop at 4, or p of 4, there are 3 sections in this spinner which are numbered 4. Therefore, the probability is 3 over total number 8. So 3 over 8. Now, in letter B, we are asked to determine if this distribution, or to convert it first, into a distribution or a table, and then to determine if that distribution is a probability distribution or not. So, converted into a table, we have two arrows again. The first is for x, or the values of the discrete random variable. Since these are the number of, we have here the number of sections, 1, 2, 3, and 4. This will be the values of x. And then for the second row, this will be the corresponding probability of each. We derive these values from our solutions in letter A. If the section is 1, the probability is 1/4. 1, the probability is 1/4, and so on. Okay, is this a probability distribution or not? Again, a probability distribution satisfies two conditions. The first is that each p of x is between 0 and 1. And it is obvious from this table that each p of x is between 0 and 1. So the first condition is met. Check. For the second condition, the sum total of all p of x values must be equal to 1. If we try to add these 4 p of x values, you'll see that they are exactly equal to 1. Therefore, the second condition is also met. Both conditions are met, and therefore, it is a probability distribution. Example 3. Determine whether the distribution p of 1 equals 1 over 7, p of 2 equals 2 over 7, and p of 3 equals 3 over 7 represents a probability distribution. Justify your answer. Okay. For the first condition, we can see that each p of x value is between 0 and 1. 1 over 7, 2 over 7, 3 sevens, each. Each of these is between 0 and 1 because each is a proper fraction. The numerator is smaller than the denominator. That indicates that it is between 0 and 1, or less than 1, or between 0 and 1. And then for the second condition, their sum must be equal to 1. Let us try to add them. Since these are proper fractions or similar fractions have the same denominators, then we'll just add their numerators. 1 plus 2 plus 3 is 6. So the total is 6 over 7. It is not equal to 1. Since the total is not equal to 1, then it does not meet the second condition. One condition is not met, therefore, it is not a probability distribution.
What you have learned is a good armor in shaping your future. With God's guidance and permission, you can build a good future by considering definite plans. Those achievable plans are the values of your discrete random variable vision in life. Do not forget to make every p of x or plan count while assuring that the discrete variable or end goal is according to God's will. Until next time!